Imagine a city that never sees another sunrise.
A family survives beside one heater while the world outside freezes.
Earth drifts through darkness, carrying its oceans, its moon, and the last pockets of life. To understand how we get there, return to the final ordinary morning. Nothing looks unusual. Sunlight warms the park, powers the trees, and sets every shadow. The sunflower turns toward the sky. Birds fly. People follow routines built around daylight. That light is more than scenery. It is energy arriving from 150 million kilometers away. It feeds plants, heats the ground, drives weather, and keeps the planet's surface habitable.
Now suppose the sun vanishes instantly, with no warning and no explosion.
The camera pulls back, and the familiar park becomes a tiny patch on a rotating planet. From space, Earth still looks normal because sunlight already in transit keeps arriving. Light does not cross the solar system instantly. It travels at about 300,000 kilometers each second. From the sun to Earth, that journey takes roughly 8 minutes and 20 seconds. At the moment the sun disappears, nothing on Earth changes yet. The last shell of sunlight is already moving outward through space. Gravity changes do not reach us instantly either. They propagate at the speed of light. For those final minutes, Earth continues along its old orbit as if nothing happened.
Then the final light reaches the planet and the delay ends.
Daylight collapses across the park. Blue sky becomes black, and the sun is simply gone. Shadows disappear. Streetlights wake up. Birds and people react to a night that arrived without sunset. The moon also goes dark, because moonlight is only reflected sunlight. Stars become visible, but they provide almost no useful heat. The temperature does not plunge instantly. Earth has stored heat in its air, land, and oceans. During the first hours, cities use artificial light and existing power to continue. Traffic slows, animals become confused, and demand for heating rises sharply. Solar panels stop producing immediately. Wind and hydroelectric systems may continue for a while. Fossil fuels and nuclear plants can still generate electricity, but distribution becomes the real emergency. Every hospital, home, data center, and water pump competes for limited energy.
By the end of the first day, the crisis is no longer darkness, and it is heat.
Inside one apartment, the family closes curtains, blocks drafts, and gathers around the warmest corner. The heater can delay the cold, but only while electricity or fuel remains. Windows frost from the edges. Rooms far from the heater become unusable. People wear layers indoors, share hot drinks, and reduce the space they try to keep warm.
This is the first rule of survival. Preserve energy, then preserve water and food.
Plants are the next major failure. Without light, photosynthesis stops almost immediately. A plant can survive on stored sugars for a while, but it can no longer replace them. Fields stop growing, harvests end, and supply trucks deliver what was produced before the darkness. Store shelves empty because the food system depends on continuous farming, transport, refrigeration, and power. Livestock and stored grain extend the timeline, but they cannot support billions indefinitely. The surviving energy sources become heat, food, and time converted into electricity. That electricity must be routed to places where controlled agriculture can continue.
Survival moves underground, where rock provides insulation from the frozen surface.
A shelter needs more than walls. It needs power, ventilation, clean water, waste recycling, and repair crews. Grow lights replace the sun for compact crops, but every leaf now costs electricity. People ration food, maintain machines, and reuse heat that would otherwise escape. Geothermal energy and nuclear power become especially valuable because they do not depend on sunlight. A small underground habitat might endure, but it would be fragile, crowded, and difficult to expand. Above ground, the familiar park changes from a dark city landmark into a frozen plain. Snow buries paths and benches. Lakes freeze from the surface downward. The atmosphere cools more slowly than most people expect, while the deep oceans release stored heat. Over longer timescales, much of the surface becomes sealed beneath ice. Yet ice is also insulation. And far below it, liquid water may persist for an extremely long time. Without the sun's gravity, Earth no longer follows its old orbit. It continues in the direction it was moving, becoming a rogue planet in interstellar space. The moon remains gravitationally bound to Earth, so the pair travels together. The sky grows darker as the last reflected sunlight fades behind them. Earth's surface freezes, but radioactive decay and leftover planetary heat continue below.
The planet is not a dead stone, and it is a layered world with energy trapped inside.
The camera now descends through ice toward the place where that energy still reaches life. Deep below the ice, hydrothermal vents release heat and chemicals from Earth's interior. Microbes can use those chemicals to build organic matter without sunlight. Around them, entire ecosystems form: worms, crustaceans, fish, and other specialized organisms. Most surface life would disappear, but some deep ecosystems could continue for millions of years. Human survival would be far less certain, dependent on technology, energy, cooperation, and luck. The sun is not just a lamp in the sky. It is the engine of the world we know.